Great. So thanks everybody for coming. So everybody was at the keynote and saw the demo and introduction? Great, good. So what we're going to do today is go into more detail. We're going to show you more demo and want to be interactive. So I want please people to ask questions. So, but first we have the beta sites. What's that?
Take your hand up about it.
Uh-oh. You told me not to do that too. Okay. So there's on your seats, there's a link where you can go get access to the beta of the software and access to AWS, free credits on AWS. And it'll give you, depending on which instance you use, it'll give you 2, 3, even 4 weeks of full-time use of it. So encourage all of you that are interested to go on, get the beta, use the AWS credits, and start playing with the solution. So to start, what I'd like to do is introduce everybody first, so you know who's up here. I'm Kevin Ryan. I'm with ARM. I'm responsible for software ecosystem. So I've been working with Docker for the last 7 months to get ready for this this launch of this product. So we're real excited about what we're doing here today.
Yeah, hi there. I'm Jeff Underhill with Amazon Web Services, and we launched A1 instances in November last year. Solving the developer experience here with the Docker Desktop release gives you guys kind of an easy way to build and test locally. With the launch of the A1 instances, we make ARM available in the cloud just as easy as every other EC2 instance. So when you guys are ready to deploy and test at scale, we got you covered.
All right, go ahead, Adam.
Sure. So my name is Adam Parco, Director of Engineering for Edge and IoT at Docker. And the reason I'm here is because when you get to IoT devices, it's predominantly ARM devices. We have lots of customers asking for ARM support, improved ARM support. How do we build ARM builds and everything? So really excited to have this partnership together where we can make that easy for you guys.
All right, and then I'm Jayson Andrews. I'm also coming from ARM with Kevin, so I work in the software tools group at ARM. And so we've been working back and forth with Docker to make sure the Docker Desktop and all the other Docker offerings are working well in the ARM architecture. Okay, go ahead.
Great. We'll start with, I promise this is mostly going to be about the product and demos, but we've been doing briefings with Docker captains and the community folks over the last few days. And one of the things we're finding is a lot of people aren't as familiar with ARM and what we're doing here at ARM. So I just want to give you a little bit of background on ARM, and then we'll jump right into the product so you see what we're doing. So, in the first 22 years of existence, ARM shipped about 50 billion chips. From 2013 to 2017, we shipped as many as we did for the whole 22-year history. We expect that number to double in the next 4 years to 100 billion chips, in the next 4 years. So a lot of ARM out there. Go to the next slide. And one of the things that's driving this in the industry, and Steve talked about this a bit on stage during the keynote, is we're seeing a lot more compute and data being generated at the edge and at the device level. It used to be, right, as the internet started out, there was central distribution of video to phones. I always joke it was cat videos to your phone was the main purpose of the internet. It wasn't quite cat videos, it was things like Netflix, but that was the primary driver of traffic. What we're seeing now is that more and more traffic is being generated at the device, at the edge, and it's driving a whole new way to deploy networks and where you put your compute in the network. So this is what's driving, sorry, that mic keeps cutting out. So that's driving a lot of the traffic in the internet, and I think it creates a great opportunity for the developers to develop for this new changing edge infrastructure that's happening. Next slide. And I'm going to let Jeff talk about this a little bit, the Amazon EC2 A1 instances.
Yeah, so I mentioned during the introduction that we launched the A1 instances at Reinvent in November last year. So we now have ARM instances available in the cloud. We're seeing people looking at these for kind of containerized microservices, web scale-out type applications, augmenting an existing ARM development environment. So maybe people developing for IoT and embedded that want to have a scalable, on-demand dev and test environment. Containers is clearly an application delivery vehicle that's gaining adoption in all of those areas. And so seeing the improvements that are being made here and the preview that's available to you guys this week, where you can seamlessly build multi-arch images, push them up into your image repository, and then deploy at scale in the cloud and just have those images kind of pull down. It provides a lot of flexibility and a seamless experience for everybody. So we're making sure that here today, you've got access to those bits via the beta program, and then also some cloud credits from AWS so you can go and spin up instances and experiment afterwards. All of the traditional Linux distributions that you know and love are available up there: RHEL, SUSE, Ubuntu, Amazon Linux 2. There's also Debian, Fedora, some of the BSDs. So everything that you need should be available for you to go and start experimenting and testing these things out. And we'd love to hear from you how your experience is going. And if you have questions, track us down and let's make sure we give you guys what you need to go and play and build cool stuff.
So the Docker platform, you may have seen this slide before because everyone at Docker loves this slide. It really shows the breadth of the platform, that it's used everywhere for everything, and we're constantly expanding it. And we're doing that today. So Docker Desktop. It's the de facto standard when it comes to developing containerized applications on your desktop. Used by millions of developers every day around the world, and it forms the backbone for their development workflow and their execution environment. This is kind of the technical architecture of how Docker for Desktop works. Docker for Desktop is the convenient way to consume Docker. It bundles and configures many things for you that makes getting up and running and developing containers on your desktop very seamless and painless. So on Windows 10 and Mac, there's hypervisors that get bundled and installed as part of Docker Desktop. It's responsible for running a lightweight Linux kernel called LinuxKit. It's a containerized OS, and it's packaged with QEMU, an emulator. And we do all the configuration of QEMU to allow you to run non-native binaries and run them through QEMU. So you can see here that there's 32-bit ARM v6 and v7 images running. There's 64-bit ARM v8 images, and of course your native x86 64 running, all very seamlessly with one application code at the top, as you can see. You'll see the real power of this in the demos that Jason's going to do in a minute.
Mm-hmm. Okay.
So how do we do all this? Well, introducing BuildX. First you say is, what's with X? Well, X stands for experimental, and it also stands for extended, but I like to think it stands for extreme, because we're adding a bunch of cool new features that makes things very easy for you. So with BuildX, you can build a multi-architecture image, link them all together with a manifest file, tag them, and push them to a registry, all with a single command. And to do this, you leverage the Docker Desktop stack that I described in the last slide.
Okay.
Yeah, I guess. Yeah, so one last important thing, right, is that there's no changes to Docker files or source code needed. With the tooling we're releasing today, simply rebuild your image, and you can start deploying and testing on ARM-based servers and devices.
Okay, so that's a little bit of an intro, kind of what we've been doing with ARM and Docker. And I think what we're going to do now is just sort of jump into some demos so you can get a little more feel for what we're working on. So Part of this is kind of what you saw in the keynote, so if anybody was there, you can see it a little closer this time. It will go a little slower and show you some more of the information. So we've got two demos that we're going to share today. The first one is a PHP application. It's just kind of a hello world thing just to get warmed up a little bit and get the hang of the different architectures that we're going to run here. So the first thing I'll put up is the Docker file. So you can see it's a normal Docker file, no special stuff in there related to ARM. It'll be the same across any architecture that you use. The example itself is just a kind of hello world type example. So we stuck a uname in there into the code. So if you run it, you'll see it'll pop up with uname-m, which will tell you the architecture on which the image is running. We'll see that in the demo. And then the interesting part, I think, is the buildx that Adam just covered. So here you see the top part of the screen. We have the buildx command with 3 different platforms that are supported there now. So the idea here is we're going to run a single command, and then it's going to build a Docker image from that Docker file for all 3 of those platforms, the ARM64, AMD64, and then the ARM v7. And then it's going to push that to my Docker Hub account, and you'll see a single item there on the hub, and then depending which platform you're on, when you go to run it, it'll pull the one that it knows that it needs, and we'll show you how you can use Docker Desktop to actually run all 3 of those architectures right on the Windows laptop that I have here now. Okay, so we're not going to do any building today for the demo. It takes a little time. We can just keep moving and probably learn a little more if we just skip over that step and move into the next part. Okay, so first thing I'm going to do there in the terminal is run inspect. So let's put the command up there so you can get a look at it. So that's buildx image tools inspect, and then that's the image that was just created by the buildx. And you'll see what it prints out down here on the bottom. 3 different architectures. So we have the Linux ARM64, and then we have Linux AMD64, and then Linux ARM v7. Right? So that's the result of the buildx. You get all those different architectures that you can run. Okay, so what we're going to do next is actually run those. So if I pull up a run script here, there's 3 lines there you see on the top. So we have the first one, which is going to run the native AMD64 image, and that's going to run the PHP application on port 5010. And then the second one is going to run the ARM64 image that we built running on port 5011, and then the last one, the ARM v7. So if you're not familiar with ARM architecture, sometimes there's some confusion about what's what, so I'll just give a quick intro on that. So if you see anything that's ARM64, you might also see ARC64, and same thing on v7, you might see ARM32 or ARM v7. There's kind of a couple names that goes by depending what kind of a OS you have and what kind of a software stack. But generally, those are the 2 main ones that you'll see. Okay, so let's go down here and run that. So we're going to run that script you see on the top, which is going to launch 3 different containers. So if I come over here on the side, you'll see the 3 containers coming up there with the green triangles there. So now I have 3 containers running on my laptop for each of the different architectures. And then what I'll do is move over to my web browser here. And then we'll hit the first port, which is the 5010, and we just have kind of a hello world thing. And it says hello, and it's running on the x86, 64-bit. And then we can hit the browser for the 5011, and we have another hello world message, and this one's ARC64. So that's the ARM 64-bit container that we built. And then the last one is port 5012. I'll put in the hello message again. That's the ARM v7L. So if you're running on a 32-bit device, then you could deploy this container. So you can see from this so far that, with a single buildx command, we can build for all 3 architectures. We could push it into the hub. We can pull that down on the desktop and run all 3. And then depending on, if you're on an ARM machine, whether it be the AWS A1 or Raspberry Pi or some other embedded board, you can run those directly. So you don't have to take any steps, just Docker run, and those containers will run. Okay, so that's the first kind of intro demo, just to get us warmed up a little bit. So I think I'll just kill those containers. And then let's jump over to another one. Okay, so second demo that I'm going to share here is more of a client server. So we have a device, software, and a telemetry service. So in this case, what we have is an application which is written in Java and the same application written in .NET. So we got kind of an equivalent version of both of those. And then we have a telemetry service where the device software will post data values back to the server. Okay, so this is kind of like, could be an IoT device which is posting information from sensors or some other client posting to the API of the server. And we have that in 2 languages. So again, we can do a similar type of thing here. So let's just take a look maybe at the Docker file first. Again, straightforward Docker file. So the first container is going to be the build container. So it's going to do a Maven build on that. And then it's going to first here build the application and then copy it over to another container, which is your runtime container. So again, you don't see anything related to ARM here. It's nothing about the architecture. It's just a straight Docker file which can run on all the different architectures. And then essentially what we'll get from this is 4 different applications, right? So we have the Java and the .NET, and then we have the device and the service, and then we can build those for multiple platforms, again, with the BuildX using the -- platform. So we can build for the AMD 64, we can build for ARM 64, we can build for ARM v7 again. And with a single command, pushing the whole thing to the repository, then you have everything that you need. Okay, so I think the main thing here is just to get aware of the BuildX and what you can do with it and how you can build these multi-architecture containers, and then you can use them on whatever target system where you want to run those. Okay, so let me switch over here. So again, if we run the inspect command, it's going to go out to the Docker hub, and it's going to find all those images, and then you'll see the different manifest that comes back with all the architectures that are supported there. Okay, so I think the first thing to keep in mind is if you just do a Docker run, it's going to take whatever the native platform you're on. So if you just say Docker run and you give the image and the tag, it will just pull and run. If you want to actually run the, I'll call foreign image, maybe that's not the right term, the one which is not related to the computer you're running on, that's where you want to look here at the name. So you see the fully qualified name with the SHA attached to it. So if you specify to run that one, then it will go pull the ARM image onto the Windows laptop, and then it'll execute it there. Okay, so that's really the control that you have right now on how to run each of those images. You can take a look using the inspect, and then you can go ahead and run those. Okay, so for this particular setup, what we have is Docker Compose. So we're using Compose to run the device and to run the service. So the first part of the YAML file for Docker Compose is calling out the service, and then it has the image that we're going to run, the port forwarding there, and then we have a network that's going to connect the containers together. And then same thing for the device. So we have the device image, we've got some environment variables, and then we have the URL where the device is going to post to the API, the values that it's generating. And again, those are connected by the network to keep them together. So that's kind of the architecture of it. So let's go down here, bring this back up. Okay, so what I'm going to do now is run the .NET version using the Docker Compose command, and it's going to run 4 instances of the device. And then it's also going to run the telemetry service. So if I click over here, you'll see now I have 5 new containers which are started up. And for development, I just put in the AMD 64, right? So if you're actually developing your application and you're running and debugging on your desktop, there's no sense really to run ARM architecture at this point. You're just trying to get the functionality right, okay? So that's kind of the main flow as you work through your application and get it working until you're happy with it. Then you can generate the ARM binaries and you can run them locally, or you can push them up and pull them from your repository onto a different machine, which probably has a native ARM CPU. Okay, so that's running now. So what we can do is let's come back to the browser here and then take a look at the service. And what this is on the telemetry service, it's reading values which are generated by the devices. You'll see there's 4 devices there. If I click refresh, you'll see it's submitting more data through the API there. So, it's this is a .NET version. Like I said, there's a Java version of the same thing, but you can run that right on the desktop. And then when you're happy with it and you like your application, then you can go ahead and use the buildx to compile the ARM image for that and push to the repository. Okay. Okay, so let's shut that one down. Okay, so next thing what I'm going to do is go to the Amazon A1, and we can take a look there. So what I have here in my browser, so here I'm in the AWS console. So if you go ahead and use your AWS credits that are on your chair and you register at the beta.docker.com, you can put those into your Amazon account. You can go into the AWS console here. And the interesting part is this: when you push launch image, what you want to look for is on the right side that you can run ARM images right down here. So the one I'm actually going to run is 1804 Ubuntu, and then I would select ARM64. Right, so that's a cloud server running there in the AWS with what's called the A1 instance, which can run ARM OS. Okay, so that's been very popular for even embedded developers now. So it used to be in the embedded domain, everybody spent a lot of time cross-compiling, right? So you're on your desktop machine, you kept cross-compiling for ARM, and then you copy all this stuff to the boards, and then you fiddle around for a while, of course, because you're always missing some files and wrong library, and eventually you get your applications to work. So, what we're seeing a lot now is people moving to this type of environment where they can do remote builds. Of course, you can put all this in containers and move it right to your board, and it really takes out tons of hassle that was before in a typical embedded development environment. So that's the A1 in the AWS console. Let's go back here. So what I have now is I have one running instance that I'm going to use for the demonstration. So let me just highlight that one. And you'll see I'm running here in the US East 2A availability zone. That's in the Ohio region. And the machine type is an A1 medium. So that's one of the smaller A1 instances, but it's perfectly fine for the demo that we're going to do here. And then the public IP address is right there. Starts with 52. Okay. So that's running now in AWS. So what I'm going to do now is come back over here, and what I've done is SSH into that machine. And I'm going to, let's run the, let's do this first. Okay, so this time I'm going to run that hello world again with the PHP that I showed first, but I'm going to run it on the ARM server. So in this case, you'll see I'm just calling out the same Docker image. It has my hub account name and the name of the image. And when I run that, it'll start the container. And if I come back to my browser now, I want to go to my cloud server. All right, so if I come here and I go to this one, you'll see in the URL on the top is actually, that's the internal address of the AWS server, and I put the hello message, and I have ARC64, right? So that shows that's a cloud server running Ubuntu 1804 on ARM CPU, and I can run the same container that I built with buildx right on my Windows laptop. So I push to the hub, I pull it down to that A1 instance, I can run the container immediately.
One important thing to note was that he didn't specify the fully qualified path there because he's running natively on ARM64. Docker just figures it out and pulls the correct variant. Only use the SHA when you're running through emulation on your desktop.
Exactly. So you can see it's pretty transparent to go and run that container. Okay, so let's doing okay on time. Let's back up one. Okay, so we also have the other demo that I showed previously with the device and the telemetry service. And it's same thing. We can run Docker Compose right on the ARM server here. I'll just do a run. And then it'll start up the same application. So this one is actually the Java version of that same telemetry application. So I did the same. I started up 4 devices, 1 service, and it's running in that AWS A1 instance. It's running now. Okay, the last thing I want to show is Raspberry Pi. So what I have here is a Raspberry Pi. If you don't believe me, I did cat etc OS release. I can even do uname-a. And you'll see it's a Raspberry Pi, ARM v7. So I've SSH'd into that, and I can do the exact same thing. Now, what I'm going to do here is I'm going to run just the device part. So if I go back to my browser and I check the service in A1, you'll see it's just starting up. Let's give it a minute. Okay, so I have 4 devices which are connected. It's submitting readings there, so there's 5. Push refresh here a couple times. So it's running on the machine. You see there's my public IP address from the A1. Starts with 52 like I showed before. And that's running right now on the cloud server. So now if I come down here on my Raspberry Pi, I'm just going to run the device side of the application. So it's a Spring Boot Java application, and it's starting up now on the Raspberry Pi, and then it's going to use the API to start sending data to that A1 server. Okay, so it's sending those up now. And if I come back on my browser, and you see I have 4 device instances that I had in the other container, and I push refresh, now you see there's 5, right? So I've made a direct link between a Raspberry Pi running that Java application using the API and the cloud server and AWS A1, and all with the same containers that I built on my Windows laptop. Okay, I couldn't show that totally. It takes a few minutes, but you'll have to trust me. It's in my hub account. We use BuildX. We pushed all those things up, pull it to the Pi, pull it to the A1, and you can see it's all very transparent to just run those containers. Okay, so just as a summary, I guess, what did you see? You saw BuildX live and in action for the first time. It's available now in the Docker desktop on the Edge release. So if you go download the Edge release, you'll get the BuildX command. You can start in on this right away. We showed how to build those images from multi-architecture. And then we showed how to run those either on your desktop using the instruction translation. So it's translating ARM instructions into x86 instructions when I ran that PHP Hello World. And then we showed how to run it on AWS, the A1 instance, which is also built on ARM CPU technology, and then on the Raspberry Pi, which is also running Linux with the ARM Cortex A53. So hopefully you saw, lots to do with building and sharing and running, kind of all with the latest and greatest stuff on Docker Desktop with ARM. Okay, so I think we're going to wrap up there and see if anybody has any questions. We can take those. Yes, go ahead. Outside of Edge, Adam, so.
So it's an experimental feature right now. We're going to be working on getting that GA'd, and we'll drop the X. I don't have an exact date for you right now, though. Sorry.
Go ahead. Right, okay, so if you build ARM images and you run them locally on a Windows laptop, there's instruction translation which is going on there, right? Because the ARM images all have ARM instruction set. And they're not going to run. So that's where Docker Desktop is transparently doing that translation for you, and you don't even see it. I mean, it's just kind of in the background, and it's running those ARM images by translating from ARM to x86 instructions. Now, when we go to the Raspberry Pi or to A1, it's all native, right? So it takes the container and runs it directly on the CPUs that are there because they're ARM CPUs. So that's the difference.
So
Yeah. Go ahead.
So Docker determines the native architecture you're on, and when you do a Docker run or Docker pull, it uses that information to pull the correct image from the manifest. But with Docker Desktop, if you give the fully qualified path that includes the SHA, it basically pulls the wrong architecture for your host device. But then with the technology stack of Docker Desktop and Emulation, we're able to run that non-native binary and run it through Emulation.
Right. So what I put on the top of the screen there, that's really, I think, what you're asking. So the first one just has the name of the container, the image to run, and the second two have this fully qualified path with a long string. Right. So when you specify one of those, it will go get that image, and those are going to be the ARM ones. So it says, okay, I'm going to run this. I can see it's an ARM image. I need to translate the instructions and run it on Docker Desktop. So if you don't put any fully qualified path, like Adam said, it'll get the one for the machine you're on. Is it okay? You seem a little confused, but. Same. Right. Yeah, that's right. So what you see, I guess, maybe, if I go in my hub account here, it's probably a good place to see it. So if I open up this one, I only see one thing there, right? I don't see that there's an ARM 64, there's an ARM v7, there's an AMD 64, but they're in there, right? So that's the multi, platform container. Okay, anything else? You can, yeah. So I think what's probably going to happen is people are going to figure out the use cases. I mean, everybody's environment has different, I'll call stress points, right? Some people have stressful compiling, some people have stressful runtime, some have both, and some have neither. So I think what you have to kind of learn is what is the best way to, build your containers and how to run them and what's most efficient, right? So if I would build, a very complicated, let's say a build container, it probably could be built a lot faster on A1 if I give it 8 CPUs than if I try to build it on, weak Windows laptop or something, right? And vice versa. I mean, the runtime is the same thing. So you can do the build and you can do the run, and it's all transparent. But there's obviously some performance overhead that goes with it, depending. In some cases, the Windows laptop is faster than the Raspberry Pi, so it's way better to build here and just run the container on your embedded device. So yeah, it's transparent functionally, but there's definitely some performance trade-offs, and I think people will probably figure out what's the best way for your projects to build remotely or build locally and test, where you want to test the containers. Anything you want to add on that, Adam?
No, that was a great answer. Yeah, but like you said, every app is kind of different. And then we also describe things as inner loop and outer loop in development cycles. So if you're writing, say, a very small microservice application, and you just want to iterate and test something locally on your development machine, you're on a train, you have no internet or something, you don't want to use a remote build instance, right? This is handy, but like Jayson was saying, if you got some big, massive complex build process, you probably don't want to ship that off in CI/CD or use a remote builder, but then you still might want to be able to test and run that locally as well, right? So there's it's just powerful that you can mix and match and
Right.
fill in all use cases, really.
Yeah, I think the flexibility is the big thing. Like, for example, I have a machine learning stack that I work on a lot, and it's a C++ stack, and it takes like an hour and a half to build on the best machine you can find. And so that wouldn't be something that I would want to build necessarily and run in an ARM container on the Docker desktop. It'd be much better to build it on the A1 and then take the container and then iterate on the application itself, right? Because normally I'm changing like the top level application, but there's all these libraries underneath that have to be built. So that part, you kind of have to be smart about. Okay, I don't want to rebuild the hefty stack, but I want to just change and iterate on that inner loop with the application itself, which is using all those libraries. So, that would be a great use case for desktop, whereas the large giant compile is probably not the best because there's other ways to do remote build faster. So, okay, other questions? Yeah, here, give the mic to Jeff.
It's off.
I'll push the button.
Yeah, so they're standard container images that will run in ECS, EKS, or Fargate. If you're asking specifically about ARM, then ECS exists for the A1 instances today. The EKS support for ARM was announced as a public preview last week, and Fargate does not exist for ARM today. So it would, but the availability isn't across the board yet.
Okay, any other questions? We have a couple minutes left. Yeah, go ahead. Yeah. Yeah, so I mean, if you have to start with an image that has a multi-architecture support. So if you just go on the hub and you turn on the filter for ARM64, I think there's 100 plus of those. So if you start from there, yeah, it's already there for sure. But you definitely need to start from one of those. And I'm sure there's lots on the hub that don't have the multi-architecture. So find one that does would be an idea. Anything else, Adam? Or? Okay, anything else? All right, so let's wrap it up. So if you want to get started, we've got a couple things. One is here, which is beta.docker.com. So what you want to do is push that blue box, and there's a few different choices here. So the one that we're talking about right now is the third box. So Docker Desktop CE with the multi-arc images, ARM enabled. So you can click that box and put in your registration information. And then you can gain access to the AWS credits and the latest information about Docker Desktop. The other thing I will point out is here, if you go to community.arm.com, that's our ARM community site, we have a new blog there which basically goes through all the steps that I just did, right? So if you go off and get the Edge version with the BuildX, and you go to community.arm.com, it should be on the front page. There's an article here which will go through all the installing Docker, exploring the ARM images, and running pretty much all the stuff I just did. So if you're looking for instructions, you can definitely take a look there and get up and running very quickly. Okay, so with that, thanks everybody for coming. Hopefully it was informative. You learn about our Docker and ARM partnership, and have a good rest of your DockerCon. Thanks.